Welcome. So imagine just sitting in your living room, right? And you turn on the lights, you adjust the thermostat, maybe you even initiate this whole complex sequence on your computer, but you do it entirely with your thoughts. No more hunting for that TV remote buried between the couch cushions. It sounds like pure science fiction. But with brain computer interface technology, or BCI, using these non invasive headsets like the Emotive Epoch, this wild dream of direct neural communication, it's actually becoming a tangible reality. The tech literally picks up your brain's electrical activity, your mental states, facial expressions, your attention levels, and translates all of that into commands. But okay, before we get too carried away with all these sci-fi possibilities, we really have to talk about the reality of where this tech sits right now, and honestly, the major roadblock keeping it from basically taking over our smart homes. So ask yourself this. What if your thoughts can orchestrate an entire room rather than just, clicking a single button on a screen? That's the ultimate vision for intelligent environments. But here is the incredibly frustrating current reality of BCI. Right now, most of these implementations are severely limited. I mean, if you put on one of these amazing EEG headsets today, you're basically tethered to a single device. One headset controls one application, or one single piece of hardware at a time. It's an incredible party trick for sure, and it's great for basic demos, but if you actually want to orchestrate a real-world smart home, manage assistive technologies, or control this whole distributed network of IoT devices, this one-to-one approach just completely falls flat. You literally can't seamlessly switch from controlling your robotic vacuum to your smart lights without completely rewiring your connection. It's just not practical. Okay, let's get right into it. Part 1, the one-to-one bottleneck. So here is the fundamental problem keeping this whole technology from scaling up. On one side, we've got our current state. One headset equals exactly one device. It's kind of like a conductor who can only command one single musician at a time. I mean, perfectly fine if you're doing a solo, but completely useless if you want a symphony, right? But then on the other side is the goal of this totally new architecture called Synaptomesh. The idea here? One single EEG headset orchestrating a massive heterogeneous network of devices all at the same time. Just think about the potential here for smart homes, complex robotic systems, assistive tech for individuals with disabilities, and even massive IoT infrastructures. To make these systems actually useful in the real world, we absolutely need a unified architecture where brain signals don't just go down one narrow little pipe, but instead they fan out to securely and efficiently orchestrate an entire ecosystem. So what exactly is causing this bottleneck? Well, looking at the research, it breaks down into a few really critical architectural flaws in how we currently use these EEG-based systems. First off, there is absolutely no distributed control architecture. When your headset reads a signal, there's just no centralized system there to process it and distribute that command to multiple destination devices. Secondly, we have highly limited command mapping capabilities. Existing systems basically just map a simple mental command to one single device action, zero multi-device orchestration. And finally, scalability challenges. As it stands, you can't just dynamically add a new smart device or a new app to your ecosystem without completely breaking your entire setup. All right, part 2. Enter Synaptomesh. So this project is the proposed solution to completely shatter those communication constraints and create this real-time thought-guided command layer. And right at the center of the Synaptomesh architecture is something defined as the Master Hub. You can think of it as a centralized engine that acts as the ultimate intelligent middleman between your brain and your smart environment. Basically, the Master Hub takes the raw brainwave data generated by that EEG headset and it processes it. It extracts meaningful command labels, so it figures out exactly what you're intending to do. And then, here's the magic. It takes on all the heavy lifting of mapping and distributing those commands across a massive network of devices simultaneously. Let's move on to part 3, under the hood. So how does a thought actually turn into a coordinated action across multiple machines in a secure, real-time networked environment? Well, here is the exact data flow that makes this crazy scalable control possible. Step 1 is acquiring the EEG signals. You're wearing your non-invasive headset, like the Emotive Epoch, and you're generating specific mental states. That data is immediately sent to Step 2, the Master Hub processing phase. This is where the signals are classified and turned into distinct readable commands. Then we hit Step 3, command mapping. This is where the command classification engine basically translates your mental command into specific device actions. And finally, Step 4, multi-protocol broadcast. The Master Hub blasts these coordinated commands out across the heterogeneous network in real time. Now, that final step is actually absolutely crucial. It solves what researchers identified as this massive missing link in traditional setups, multi-protocol integration. You see, traditional BCI completely ignores the fact that modern smart environments speak a lot of different languages. Your IoT sensor doesn't communicate the same way your desktop computer does, and your robotic vacuum uses a different language entirely. But Synaptive Mesh, it is fundamentally designed to act as a universal translator for all of these wildly diverse devices. And it handles this multi-protocol integration brilliantly. The Master Hub essentially takes one unified language, your brainwaves, and it translates it into the specific digital dialects required by all that diverse hardware. For instance, for lightweight IoT nodes like an ESP32 or an Arduino, it broadcasts using the MQTT protocol. If you want to command mobile applications or web-based systems, no problem, it fires off WebSockets or HTTP requests. And for direct hardware control, think like a Raspberry Pi-powered robot, it can just use serial communication. It literally bridges the gap between biological signals and heterogeneous computer networks perfectly. Which brings us to part 4, a connected future. So this is where all this incredible engineering and architecture is actually leading us. A seamless, cross-platform, smart environment controlled entirely by thought. To kind of summarize the massive leap forward this research represents, let's look at the expected outcomes of the Synaptive Mesh framework. First off, we're moving from that rigid one-to-one setup into a truly scalable network. We get real-time EEG signal processing mapped to instantaneous multi-device command distribution. We also gain cross-platform interoperability, meaning, honestly, it doesn't matter what operating systems your various devices are running on. And most importantly, you get scalable smart control. This gives you the freedom to dynamically add new devices to your environment. Say you buy a new smart speaker. You connect it to the network, and instantly, it can be orchestrated by your Master Hub. It truly feels like we are right on the precipice of a totally new era of human-computer interaction, you know? We're finally breaking down that one-to-one bottleneck and allowing our intentions to just seamlessly flow into the physical environment around us. So I'll leave you with this final thought. When your smart environment can finally read your mind effortlessly across all your devices, what will you command first?